For those in the planning field, what I've just described is a process that is completed by a number of different planning documents. Both the hazards and climate change fields have a portfolio of planning documents that approach problems with the same process. This thesis focuses specifically on climate action plans, which I'll refer to as CAPs, climate adaptation plans, which I'll refer to as adaptation plans, and local hazard mitigation plans, which I'll refer to as LHMPs. There are also a number of other planning documents that would be filed within this section, including safety elements, recovery plans, emergency operation plans, ordinances, and many others, but in this thesis I keep my scope primarily to these three plans. What is unique about these plans is that they all have the potential to overlap. This thesis proposes one way in which all these plans can work towards the same goal of resilience. All these plans are arranged in a straightforward and logical way. They measure the current state of a jurisdiction and then propose strategies to reduce emissions or losses. Climate action plans measure the greenhouse gases emitted within a jurisdiction. For example, the number of vehicle miles traveled and the building energy use within a city, and then suggest strategies that could reduce emissions in the future, like increasing the share of trips completed on bicycles or investing in photovoltaics. The plans often measure greenhouse gases as a single CO2 equivalent factor. This measurement simply combines all greenhouse gases into a single denominator of CO2. Local hazard mitigation plans follow a similar process. They map hazards like floods, fires, and earthquakes, and then calculate the expected losses due to hazard events. Strategies are then recommended that reduce the losses of future hazards. In the past, LHMPs have used primarily historical data to project future hazard levels, often marking the average hazard and then a maximum probable or low probability event. For hazards like earthquakes that aren't expected to be altered by climate change, the historic LHMP process is sufficient. For other hazards, however, climate adaptation plans are used to account for science that suggests certain hazards are expected to be exacerbated by climate change. So we have plans that measure disaster losses, and we have plans that measure greenhouse gases, but currently there are missed opportunities in each for strategies to overlap that reduce greenhouse gas emissions and reduce hazard losses. The next chapter walks through the methodology used to study the greenhouse gas emissions of disaster losses.